problem is a little bit, a little bit different because you have to solve something, and then once you know that, then you can get the answer. So if you look at this, we have a 3-kilogram model rocket is launched vertically, so we're launching it straight up in the air with sufficient initial speed to reach a height of 100 meters. So it's going to get up to 100 meters, even though air resistance does 800 joules of work on the rocket. How high would the rocket go if there was no air resistance? So it's going to go up in the air because there was some type of energy that it had when it left the ground, and we want to figure that out. And then once we know the energy that was needed to get it up into the air, then we'll just exclude work and figure out how high it's going to go. So the first thing, like all problems, we're going to begin with the formula, the law of conservation of energy combined with the work energy transfer theorem. So that's our starting point. And in this particular problem, we're starting on the ground. So what should I make 0? Well, yeah, KO is going to be 0 because we're starting on the ground from rest. And UO will be 0, right? So both of these are going to be 0 because it's... Well, no, wait a second. No, that's not true. Because, yes, at some point the rocket wasn't moving. But... Move this out of here. At some point, the rocket wasn't moving, and we had to give it an energy to get it up into the air. But we're already saying that we need to know, well, what is that energy that it had? So we're not starting it from when it's 0. We're starting it from when it actually started moving up. All right? So that means that since it's starting from the ground, I can cancel this out, but I cannot cancel this out because that's what's going to make it go up into the air. Just like if I throw a baseball into the air. While it's in my hand, yes, at one point the baseball wasn't moving, but we're starting the motion from the moment it leaves my hand, and with this one we're starting the motion from after whatever force is applied to give it that kinetic energy. Now, when it goes up into the air, it's going to go 100 meters up into the air. So at that point, what will be its speed? 0. So what else is 0 in this problem? KF. So what I'm going to do here is I'm not going to, like in a lot of these problems, what we do is we replace KO with 1/2 mv/o squared. We replace work with force times distance. We replace this with mgh. But in this particular problem, I just want to know the total energy. And they didn't give me any information about the velocity anyway, so I just want to get this number. Because that's going to be the number that I'm going to use to then figure out how high it would go without work. Now they're giving me work here. They're not giving me the force and the distance, so I don't have to write that as F times D. Now I do have to write this as mgHF because they gave me the H. So this one has to be broken down, but these two do not. So I'm going to just bring down the KO, and I'm going to bring down the W, and the only one that gets broken down, I'm going to replace U with MGH. Since it's UF, then it's HF. So that's my equation. So the unknown in this problem is going to be the original kinetic energy. Because once I know that, then I'm just going to redo the problem without work. Now, this work is, because I forgot last time, I'm not going to forget this time, I'm going to right now make it a negative because I know that this work is a negative work because it's due to air resistance. And air resistance is a frictional force that opposes motion. So whatever direction it's moving in, that would be reducing the amount of energy. So I'm going to do it right now so I don't forget later. And if I solve for KO, KO is going to equal mg h final plus W. So I've already dealt with the direction of work. So yes, moving it on the other side, it's now plus, but I'm not going to now put a negative sign in there. I've already done that up above. So solving for KO, it's going to be mg hf plus W. And if we put the numbers in, the mass is 3 kilograms. Gravity is 9.8 meters per second squared. And the height is 100 meters. And it has to overcome the work, which is 800 joules. So if you solve that, what do you get for the original kinetic energy that it had to have in order to go 100 meters into the air with air resistance involved in the problem? What's that? 3,740 joules. So now that we know that, now we're just going to solve the problem again. I'll do it in a different color here. So we're going to have the same, we're going to have the equation KO plus UO plus W equals KF plus UF for part, it's really, there's only one part to this problem, but there isn't, what we had to do this first to get this. So we're still starting from the ground, so that's 0. But now there's not going to be any air resistance. So there's nothing to reduce the amount of energy of the rocket as it goes up, so that's 0. And when it reaches its maximum height, it will no longer be moving, so that's 0. So I don't have to replace KO with 1/2 MVO squared because I know what that number is. So, but I do need to replace this because we're looking for the new height, how high it's going to go up into the air. So we're going to have, our equation is going to be KO equals mg times the final height. And solving for the final height, that's going to be KO divided by mg. Yes? Kf is 0 because when it reaches whatever its maximum height is, maximum height by definition means that it's no longer going up and it's on the verge of coming down, so it temporarily stops. Right? When something goes, anytime you throw something into the air, as it goes up, it slows down, comes to a stop, and comes back down. So at the maximum height, that's when it changes direction from going up to coming down, so that's when it temporarily stops. So solving here, we're going to put in 3,140. Now, I can write that as a joule. I'm sorry. 3,740. And I'm going to write it as, instead of a joule, I'm going to write it as a Newton meter. Just so, because I know my answer has to end up in meters, and I just want to see that it works out that way. So the mass is 3 kilograms. And gravity is 9.8 meters per second squared. So this is a Newton. So the Newton will cancel the Newton units down here, and I will get my answer in meters. And if you solve that, you get what? It should 127. So it is higher than without air resistance, which makes sense. If there's no air resistance, I should be able to throw something higher up into the air, or a rocket should be able to go higher up into the air. Any questions with that?